Hello viewers, in today's class we are going to take up one important topic from three-dimensional geometry, right? So here we are going to discuss one problem which is related to the topic foot of the perpendicular and the length of the perpendicular, right? So here the problem goes like this. Find the coordinates of the foot of the perpendicular from the point P 7, 14, 5 to the plane 2x plus 4y minus z is equal to 2, and also we have to find the length of the perpendicular, right? Okay, so let us start. So here we are given a plane, and the equation of the plane which can be denoted by pi. Let us denote the plane by pi, and the equation of the plane is 2x plus 4y minus z is equal to 2, right? And the given point P is 7, 14 and 5, right? So here we have the point P, and we have to find the perpendicular which is drawn to this plane, and let this point Q is the point of intersection of this perpendicular and the plane, right? And let us say the coordinates of this point Q are alpha, beta and gamma, right? So now here we have to find the coordinates of point Q, that is we have to find the value of alpha, beta and gamma, right? And we have to find the length of this perpendicular PQ, right? And once we are able to find out the coordinates of the point Q, we can apply the distance formula to find out the distance PQ, right? Okay, so now here what we will do, we observe the equation of the plane, right? So the equation of the plane is given in this form: ax plus by plus cz is equal to d. Now we know that the direction ratios of the normal to the plane are given by the coefficients of x, y and z, right? So if the equation of general plane is ax plus by plus cz is equal to d, then the dr's, the direction ratios of the normal to the plane, are given by a, b and c, right? So let us take the normal like this, right? So this is the normal to the plane, right? And here we see that this is the perpendicular PQ, and vector n is the normal to the plane. So this PQ is parallel to the vector n, right? Okay, and we know that if we have two parallel vectors, then the direction ratios are proportional, right? Okay, now we will write the equation of this line PQ, right? So this is given by x minus x1 over a, y minus y1 over b, and z minus z1 over c. So this is the standard equation of the line in three-dimensional geometry, where x1, y1, z1 are the points through which the line passes, right? So here x1, y1 and z1 is the point P, which is 7, 14, 5, right? And A, B, C are the direction ratios of this line, and here the vector n is parallel to PQ, hence the direction ratios of these two lines are proportional. Hence we can take the direction ratios of the line as 2, 4 and minus 1, right? 2, 4 and minus 1. The coefficients of x, y and z are the direction ratios of the vector n, right? So now we can take these values here and we can define the equation of the line PQ, which is given by x minus 7 over 2, y minus 14 over 4 and z minus 5 over minus 1, right? So this is the equation of the line PQ, right? Okay, now here we see that the point Q, it lies on the plane as well as on the line PQ, right? So let us here find out the general coordinates of any point on the line PQ. So for this we have to take a scalar. Lambda is the scalar, and from this equation we can find out the coordinates of the general point, right? General point. So for this we have to equate these three quantities to lambda, right? So we have x minus 7 over 2 is equal to lambda, y minus 14 over 4 is equal to lambda, and z minus 5 over minus 1 is equal to lambda. Now if we solve these three equations for x, y and z, we see that x is equal to 2 lambda plus 7 and y is 4 lambda plus 14 and z is equal to minus lambda plus 5, right? So therefore the coordinates of the general point are 2 lambda plus 7 comma 4 lambda plus 14 and minus lambda plus 5, right? And these coordinates can be taken as this point alpha, beta and gamma, right? For some value of lambda, right? So what does it mean? For some value of lambda, this coordinate will give the point Q, right? So alpha is 2 lambda plus 7, beta is 4 lambda plus 14 and gamma is minus lambda plus 5, right? And we see that this point Q, it lies on this plane, right? It lies on this plane, so therefore Q will satisfy the equation of the plane. So therefore we can write 2 times of alpha plus 4 times of beta minus gamma is equal to 2, because alpha, beta, gamma is the point which lies on the plane as well as on the line. So therefore this point should satisfy the equation of the plane, right? So substituting alpha, beta, gamma in the equation of the plane, we get this equation. Now alpha is 2 lambda plus 7 and beta is 4 lambda plus 14 and gamma is minus lambda plus 5 is equal to here we have 2, right? Okay, now this is a linear equation in lambda. So we have 4 lambda plus 14 and here we have 16 lambda plus 56 and plus lambda minus 5 is equal to 2, right? Okay, so now we have 4 lambda, 16 lambda and lambda, so we have 21 lambda here, and 14 plus 56 is 70, 70 minus 5 65, that is equal to 2. So 21 lambda is equal to 2 minus 65, that is minus 63. So lambda is minus 63 over 21. that is minus 3, right? So therefore the value of the scalar lambda is equal to minus 3, right? So now if we take this lambda and we'll put it here, then we can get the value of alpha, beta and gamma, right? So if we take lambda minus 3 over here, we get 2 times minus 3 plus 7. Here we have 4 times minus 3 plus 14, and here we have minus 3 plus 5, right? So now here we have minus 6 plus 7, here we have minus 12 plus 14, here we have 3 plus 5, right? Okay, so 7 minus 6 is 1, 14 minus 12 2, and here we have 8, right? So therefore the coordinates of this point Q are 1, comma 2, comma 8, right? So Q is the foot of the perpendicular drawn from this point to this plane pi, right? And now we have to find the length of the perpendicular. So what we will do, we will apply the distance formula in three-dimensional geometry, which is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, right? And here we can take this point as x1 y1 z1 and this point as x2 y2 z2, right? So we can write it like this. So we have 7 minus 1 whole square, then we have 14 minus 2 whole square, and here we have 5 minus 8 whole square, right? So here we have 6 square, this is 36, and here we have 12 square, 144, and here we have minus 3 square, that is 9. So this is these three numbers add up to 189, right? So viewers, the length of this perpendicular is square root of 189, and the foot of the perpendicular has coordinates 1, 2, 8, right? So this is how we solve this problem.